In this video, I will explain how to model a laminated composite plate using ABAQUS software. So the problem is given here. We need to calculate deflection and bending moments at the center of a laminated composite square plate. The size is given as 300 by 300 mm. The dimension scheme is given as 090, and each layer thickness is 1 mm, and these are the material properties. The plate is subjected to uniformly distributed load of 4 kilonewton per meter square. The analytical solution is given here. You can check the maximum deflection is coming 1.302 mm from the analytical solution. We will compare this with ABAQUS solution, and these are the moments at the center of the plate. So at first, we'll create the geometry from the part module. So create part, cell, planar. Now create a rectangle by using this tool. Click here, click here. Now add dimension. Click on this side. Now modify this dimension 300 mm. Similarly for the another side, it is 300 mm. Then cancel the procedure from the bottom. Done. The geometry is created. Go to the property module. Create material. Mechanical, elasticity, elastic. So here you need to change the type to lamina. So lamina is for cell elements, and for 3D you can go for engineering constants. So lamina, E1 is 140 GPa, 140 into 10 to the power 3, 10 into 10 to the power 3 MPa, E2, then 0.3 is Nu12. G12 is 5 GPa, so 5 into 10 to the power 3. G13 and 23 are not given, so you can assume the same values. Now we need to create section from the from this tool. So here, cell composite. Continue. Material 1, the thickness is 1 mm. The ply orientation is, fiber orientation is 0 degree. Then second layer, again material 1, thickness 1 mm, orientation is 90 degree. Now to add another layer, go to this last box and press enter. Material 1, thickness is 1 mm, orientation angle is 0 degree. Okay. So now assign the section. Okay. You can also check the ply stacking sequence by using this information tool, square information tool here. So by using this tool, you can go to the ply stack plot here. Click on the plate. So it will show you the layers 0 degree, 90 degree, and 0 degree, and the thicknesses are 1 mm. Now go to the assembly, create an instance by using this tool. For that step module, create a step static general. Okay. Now field output manager, edit. So here for the section moments, click on this arrow, forces and reactions, and then section forces and moments. So by default it is turned off. You can turn it on. Okay. Now go to the load module. So here we'll at first create the boundary condition, roller, initial. So at first I'm choosing these two edges by pressing shift button. So for roller support, U3 will be only restrained, that is vertical deflection in the Z direction. We'll check it. Now for other two edges, I'll apply the roller support. But first for the edge parallel to the x-axis, that is this one. So rotation about x-axis will be allowed, that is UR1, all other will be restrained. Now for the another edge, this one. So here rotation about y will be allowed and all other will be restrained. Now apply the load, create load. Step 1, pressure, continue. Select the top surface. So brown is top surface. So here we need to put the value of pressure here. That is 4 kilonewton per meter square. So in Newton per millimeter square, it will be 0.004. Now go to the mesh module, part option, sheet part. So by default, it is taking 30 mm mesh size. Later on, you can reduce it also to do the mesh conversion study. So using this second option, we are meshing it. So by default, it is choosing S4R element. You can check it from here. Now go to the job module, create a job. From the job manager, submit it. So after the analysis, we will check the maximum deflection that is at the center, 1.302 mm as per the analytical solution. So here analysis is completed. Go to the results. U, it will give the deflection, and U3 vertical one. So here it is coming 1.310 mm at the center, maximum one. So 1.310 here, and here it is 1.302. Now we will also check these section moments, 46.47, 5.990. So into 10 to the 3 in kilonewton. So in Newton it will be 46.47, 5.990 Newton per unit length. So for the section moments, this variable, that is SM. So SM1, you can check it is 4.235 into 10 to the power 1, that is 42.3. And here it is 46.47. Now SM2, this one is 4.894, and here it is 5.99. Now SM3, okay. So we need to check the value at the center. So for that we can check the value by using this probe values option. Then nodes. So here for the center node here, approximately you can choose it. Otherwise you can select it in some other way also. Okay, so here it is coming almost 0. Okay, the green color. So thank you all.